Okay, so let's go ahead and move on to our second speaker. We have Elena Adams from the Johns Hopkins University Applied Physics Lab talking about the Double Asteroid Redirection Test, or DART, NASA's first planetary defense mission. Elena, go ahead and take it away.
All right, sound check, and if you guys can tell me if you see the slides.
Got you loud and clear, and we see the, we do not see the full screen view. There it is.
Okay, all right, great. So my name is Elena Adams. I'm the mission system engineer for the DART mission. Please excuse me, I am in integration and test right now. We're getting ready to launch in about a year, but we are working very hard right now to get this mission off the ground. So this is the first NASA's planetary defense mission. We're part of the Planetary Defense Office at NASA. You can see that the Planetary Defense Office at NASA, just to give an overview, does a lot of things for the nation, including the searching, detecting, and tracking of the asteroids, using ground-based and space-based observations, characterizing of the asteroids, and NEOWISE comes to mind, as well as soon-to-be-launched NEOSM as well. They plan to coordinate between all the different working groups and with other nations as well. They also do the mitigation, which is DART is the first actual test of mitigation of an asteroid threat, and FEMA exercises as well, and then they assess how well they did. Okay, so here's DART. Trying to minimize things. Here's DART. We launch next year. Our planetary launch window opens up in July 22nd of 2021. Our goal is to impact the Didymos system. Recently, we were able to, we got a name for our actual moon that we're going to impact. For a while, it was Didymos A and Didymos B, where Didymos A was the larger asteroid, and we were impacting the moon that was moving around the larger asteroid, which we called Didymos B, which was, not a very good name for a moon for a while. But now we're very happy to have a name, Dimorphos. The larger moon is about 780 meters. We're impacting a smaller moon that rotates around the larger moon with a period of about 12 hours. And it's about the size of about 160 meters. Our goal is to impact the moon of the asteroid and change its orbital period around the larger moon. The spacecraft itself is shown here. It is about 650 kilos and about 18 meters. We're also, what we're carrying with us is a small CubeSat provided to us by by ASI, the Italian Space Agency. And this CubeSat is going to fly by the Dimorphos about 3 minutes after we impact, 3 to 5 minutes after we impact, and is going to image the plume that we create after the impact. So just to explain a little bit more, I can switch over. So here's the two moons. Here's Didymos A is right in the middle. Didymos B, or Dimorphos, going around it with an orbital period of about 12 hours. We're about 6.8 million of miles from Earth at impact, or about 0.07 AU. So this is the closest approach of Didymos system to Earth. So that happens right in October of 2022 timeframe. So at first, so as you can see, after DART impact, we changed the orbit by about 1%, and that amounts to about 10 minutes. Actually, our requirement is only 73 seconds, but right now the predictions show that when we impact Didymos, we will decrease its orbit to be by about 10 minutes. So it's not much, but it is very safe because you can imagine that since the moon is only for a controlled experiment, this is a really good approach. So not only does DART do a demonstration of the first planetary defense impact, a very controlled experiment. We're also going to be demonstrating a few new technologies for future planetary missions. Number one technology that we're demonstrating is the autonomous smart navigation. We are not able to see Dimorphos until about an hour out before we impact. In fact, we don't actually even know what shape it is until about an hour out, and about an hour out where it's approximately a pixel in our field of view. So there's that, and we don't really see it until about 4 minutes out. We don't see, it's not more than 20 pixels to us. The smart nav allows the spacecraft to be completely autonomous and perform all the maneuvers to target Didymos B and Dimorphos instead of the main asteroid completely late in the game. The ground is just listening the whole time. So we are imaging the asteroid as we're going towards it using our Draco imager, which is based on LORI from the New Horizons mission. It's a narrow angle camera, and that's what we're using for both optical navigation. So that's what we're using 30 days out when we first detect the Didymos system, and all the way in while SmartNav is using the images from Draco to be able to pick out Dimorphos instead of everything else in the background and actually target towards it. And then we're also demonstrating the NEXT-C ion propulsion engine, which is the next exciting ion propulsion engine. If you remember Dawn mission, they were able to go to multiple asteroids, and what enabled that was really the ion propulsion. We're demonstrating this development that NASA has been investing into for about 16 years on DART. And to power the NEXT-C ion propulsion engine, we need very large solar arrays. And for that, we're demonstrating the rollout solar arrays, which is a first powered flight of the solar arrays as well. They were first demonstrated on the ISS, but it was just a TRL-6 demonstration where they just rolled out. We're actually going to be using to get all our spacecraft power. This is what a spacecraft kind of looks like. This is just a CAD model of it. It's a box. The rollout solar arrays are on the sides. This is the NEXT-C thruster sitting underneath a cover that we blow off pretty fast after we launch. With the rollout solar arrays, it's about 60 feet, so 18 meters long. So it's a very large spacecraft, and of course, Leachy CubeSat is shown over here as well. Okay, so just a note, we know very little about the object we're going to hit. If you look at this observation, this is an observation from VLT, from the DART team that was taken in 2019. What you're seeing here is Didymos moving through the star field. This is the kind of observation we can do right now. In 2003, Didymos came close to Earth. There were some observations done with radar, and that's where we have the radar shape model. As you said from the previous talk about Benno, we don't expect it to look exactly like it, but this is the best image that we have of the main asteroid, Didymos A. We have no idea what Didymos B or Dimorphos actually looks like, and that is one of the challenges of this mission.
2-minute warning.
So we think okay, thank you. The last 4 hours of this mission are going to be very exciting. We're basically going to be not seeing the asteroid until very close in. And at that point, the spacecraft is going to be completely autonomously navigating towards it. And what I'm showing here is what people are going to see on the ground as we're getting close in. We're streaming images real time, once per second, so it basically looks like a video to those on the ground while trying to keep the camera on Dimorphos, and our requirement is to stream at least one image in the last 7 seconds of the mission. So, what we're doing right now is integrating and testing the spacecraft, getting ready for launch next year. This is our structure that's actually in integration test right now. We are launching on a SpaceX Falcon 9, and this is our very excited team as we're getting ready. So last point to make is that we are part of the international cooperation with the ESA space agency as well. And the Hera mission is going to arrive to Didymos in 2026 and is going to look at the impact site after DART. So I think that's it. Thank you.
Thank you so much. Do we have any questions, again, either via chat or via raising your hand in Zoom? Great, yeah, comment on excellent example of different agencies working together. Okay, so again, keep thinking of questions and we'll have the discussion period later on. Good luck. It sounds like a really exciting mission that you're working on. I think everyone was really excited to hear about it.